All right, hey there, Earth Science students. Today we're going to be talking about severe weather and storms. So the first thing I want to talk about in regards to that is when you're watching the news, you're watching the weather, what it means between having a watch for a certain type of severe weather and a warning for a certain type of severe weather. Now this goes for tornadoes, hurricanes, snowstorms, anything, any kind of weather anomaly that you can think of. So a watch is going to mean that the conditions are favorable for producing a particular type of weather event, but it has not started yet. It has not happened yet. So this could be like a tornado watch. It means that the conditions are right, but there isn't a tornado actually on the ground yet. A warning means that it is actually present and it's actually happening at that time, and that residents need to get to somewhere to evacuate or be prepared for whatever particular type of storm the warning is for, whether it be a severe snowstorm, tornado, or hurricane, or that sort of thing. So, watch means you should start preparing if you hadn't done so already, and warning means you need to evacuate, you need to get to somewhere safe immediately. So a thunderstorm, let's start with that. A thunderstorm is a rainstorm accompanied by thunder and lightning, right? We've all experienced these in the spring and the summer months. Lots of rain, lots of lightning. A severe thunderstorm, on the other hand, is going to be one that's producing hail, has winds greater than 58 miles per hour, and may produce a tornado. Those are our severe thunderstorms. Luckily, we don't get too many of those around here, but they can in fact happen. So how do thunderstorms form? So clouds are going to be growing tall enough where some water vapor freezes at the top. So basically what's happened is our pressure is low enough that enough of that water vapor is moving up into the atmosphere and it's freezing at the top. And some towards the bottom or the warmer parts of the atmosphere are going to stay liquid. Now, ice particles are going to have a positive charge and water droplets are going to have a negative charge. So that charge is going to start building up. It's similar to like when you're, rubbing your socks on the carpet and you can, shock somebody, building up a static charge. That's the same exact charge that we're going to see in lightning storms. When that charge builds up and the difference becomes great enough, it equalizes, and that's lightning. Lightning is going to occur. The thunder is going to accompany that lightning, and it basically is because the air gets so heated up, it expands really quickly, and then when the lightning is over, it claps back, and that creates that sound that we know as thunder. All right, so how does hail form? Hail is a type of precipitation that is frozen, right? So what's going to happen is raindrops are going to start falling and descending through the atmosphere. They precipitate out of clouds and they start to rain down. Well, when our low pressure systems, we've got air moving up, we've got air violently rising inside of our low pressure system. And that can be sometimes enough to push that rain back up into the atmosphere. When it does that, the temperature is going to decrease, right? As we go up in the atmosphere, our temperature decreases. That's going to freeze these raindrops. Then they're going to become a little bit too heavy and start to descend back down. Once that happens, they might be pushed back up, depending on how strong the storm is, and they might freeze again. And while they're doing this, they're going to be colliding with other chunks of hail and kind of fusing together. This process is going to repeat over and over again until the hail becomes too heavy and it can't be pushed back up by that air anymore and falls down to the ground. So I've got this animation that's going to show you that. You're going to see the hail go down and then start to come back up and down in the atmosphere. It's going to go back up and down through the cloud. Once it finally hits this cold air and becomes too heavy and starts to fall, that's when it falls as hail. You can see over here on the other side, the hail is going to get bigger and bigger the more it goes back up and down through the atmosphere. The more often it goes down and melts and then rises back up and freezes some more and collides into more pieces of hail. All right, another thing of severe thunderstorms is lightning safety precautions. First thing you want to do, go inside. Second thing, avoid using electrical appliances such as telephones, computers, or televisions. If no building is available, try to get into a car. They work really well at conducting the lightning safely around you. Stay away from trees. If you are trapped in an open field, crouch down and bend forward, putting your head on your knees. Do not lie flat on the ground. You want to have as little contact with the ground as possible, because that's what the lightning is trying to do. It's trying to get to the ground or up to the cloud when it's equalizing. Okay, on to tornadoes. So a tornado is a violently rotating column of air that usually touches the ground. It's a funnel-shaped cloud of moisture, debris, or dust. So tornadoes most often occur in spring during the afternoon. And that's because they're most often occurring in association with severe thunderstorms. And that's when our thunderstorms tend to develop. In order to get a tornado, cold, dry air from Canada is going to collide with warm, wet air coming up from the Gulf of Mexico. That's why if we look at this map right here, we've got this tornado alley, right? This is where most of the tornadoes occur in the United States. We've got this one right here. All right, let's take a quick look at a video of a tornado here. So here we have that rising column of air violently. You can see all the debris kind of flying around it. So it's kind of sucking all that stuff up into the sky because the air is rising so quickly. Tornadoes are where we find some of the lowest pressures that have ever been recorded on Earth, right? We have extremely low pressure inside of these. And how do they form and when do they form? So like I said before, they form in the afternoon, usually in the spring. And that's because they form off of severe thunderstorms, right? They kind of form at the tail end of a severe thunderstorm. And most of our thunderstorms occur in the afternoon. And that's because all of that hot air that's been taking in moisture all day, as the sun begins to set and begins to cool, all of that moisture begins to condense and precipitate out. And that's how we get those thunderstorms. And these tornadoes are a consequence of those severe thunderstorms. All right, so what are some of the warning signs for a tornado? Well, if you hear a loud rumble, I've heard it also described as like a freight train, that's going to be an indication that there might be a tornado somewhere around. The air is often calm right before a tornado hits. I've spoken to people that have lived through tornadoes or witnessed tornadoes, and they often describe it, that's very calm right before. And sometimes they talk about how the sky tends to turn like a greenish color. And it occurs on the trailing edge of a severe storm. So usually a storm has already passed through that area, and then there's going to be tornadoes that are going to be trailing behind that storm. So here we have our tornado rating scale. So it goes from what's called an EF0 to all the way an EF5. And basically it changes based on how fast the winds are going, right? How quickly the winds are going inside of the tornado. And that's also going to affect how much damage the tornado is going to do. The faster those winds are moving, the more damage the tornado is going to be capable of. So during a tornado, you're going to want to get to somewhere low, get to a basement. If you don't have a basement, go to a room on the lowest floor, such as the bathroom, that's going to be, somewhat insulated from the outside. You want to go to an interior room. If you have some furniture in there, getting under a sturdy piece of furniture like a table, that's going to help you in case things start falling in the room and they hit the table instead of you. You're going to want to get out of cars. Cars can get picked up by tornadoes, and you don't want that to happen. Do not try to outrun a tornado in your car. You're going to want to leave it immediately. If you're outside, go to a low-lying area and crouch in it, like a ditch or something like a culvert on the side of the road. Even getting under bridges and that sort of thing. Anything where you're kind of protected from the outside is going to help you in a tornado. So a blizzard is a low-pressure storm over land that produces lots of wind and snow. Blizzards are kind of rare around here. Winds have to exceed 35 miles an hour. The temperatures must be 32 or lower, and visibility has to be reduced to less than a quarter mile, right? We often get lots of snow around here, but we don't usually get the snow with the wind that fast or the visibility that low. Blizzard safety precautions. So you're going to want to avoid being outside, and you're definitely going to want to avoid driving. Driving during a blizzard is extremely dangerous. So you're going to seek shelter because if you're outside in a blizzard, you are in danger of getting frostbite or hypothermia. So you're going to want to assemble a disaster supplies kit for your vehicle or for your house that includes these things. And you want to do this before, right? Like you don't want to do this right in the middle of a blizzard. That's not going to work. So first, you're going to need some first aid kit. You're going to need essential medications, flashlights and batteries, non-perishable food like energy bars, granola bars, that sort of thing. You don't want things going bad right before the blizzard hits. Bottled water, extra warm clothing, including boots, socks, hats, and gloves. If stuck, run the engine for a few minutes at a time. And be sure that the exhaust is not covered. You want all those gases coming back into the car. All right, let's talk a little bit about lake effect snow. So lake effect snow is going to form when cold, dry air moves over a warm body of water. That's going to cause a lot of evaporation, right? We've got very dry air. It's able to accept a whole lot of that water. And if we got warm water, it's going to evaporate a whole lot easier. So as this evaporation is occurring, you're going to increase the amount of moisture in the air. Eventually, it's going to get over land. When that happens, all this extra moisture is going to have to precipitate out because the air is going to start to cool down, right? And it's also not being supplied with water anymore. So it's going to start precipitating out over the land. This can lead to extremely large snow totals, sometimes, 4, 5, even 6, 7 feet at a time. We occasionally get, lake effect snow, right? Oftentimes, places closer to the lake will get more snow than places further from the lake. Now, wind direction is the key to this whole thing, right? If us in Rochester and Greece, if we don't have a wind coming from the north over Lake Ontario, we're not really going to get a whole lot of lake effect snow. Sometimes we can get it from the west, from Erie, but that's a little bit rarer, and it has to travel a whole lot further in order for us to get it. Now, real quick, I want to show you a time-lapse video of what happened in Buffalo in 2014, which was a very large lake effect snow event. So we're going to see what happens and how lake effect snow forms. All right, so here we are looking west from the city of Buffalo, and you can see, right, we've got all of this air kind of rising off of the lake. Now, as that air is rising, you can see that it almost looks like a cloud at the surface, like fog, right? This is all of that moisture that's coming up off the lake. Eventually, as soon as it hits the land, it's going to go back down. It's going to precipitate back out, and it's going to dump onto the land. I can't remember exactly what the totals were in this, but I believe it was well over 3 feet. Some places were getting, 4 or 5 feet. And that's the thing about lake effect snow. As you can see, it kind of travels in bands. You can see one part of the city is getting a whole lot of snow, and other parts aren't getting much at all. And that's usually how it occurs, right? That's why we have much heavier snow totals in local areas sometimes with lake effect snow than, just maybe even half a mile or quarter mile away. Might get almost no snow at all. All right, let's go to the other end of the weather spectrum and start talking about hurricanes, right? So hurricanes occur when warm air rises above the ocean and it begins to form clouds. So this usually happens when the Atlantic Ocean is warmer, so, later in the summer into the early fall. The clouds begin to rotate inward and a tropical depression develops. This is very similar to the severe thunderstorms that we talked about that could spawn tornadoes. But the thing is here, because these storms are traveling over the warm ocean, they continue to get fuel. They continue to grow stronger and stronger. So they turn out to be much stronger than those severe thunderstorms that we see, like in the middle of the United States. So as the warm air rises, the system continues to be fed more and more, and the storm begins to look like a hurricane. It begins to start to rotate, and it has that eye in it that we know that hurricanes have. So as that warm air starts to rise, the system continues to be fed more, and the storm begins to look like a hurricane, right? It's got that distinctive eye in the center of it, which kind of distinguishes hurricanes from other, just tropical storms. The Atlantic Ocean hurricanes form off the coast of Africa and travel across the Atlantic Ocean to the east coast of the United States. So this is because we have extremely hot and dry air over the Sahara Desert. And as that begins to move west with the global winds, it moves over the Atlantic Ocean. Now, when the Atlantic Ocean is warm, like in late summer and early fall, it's able to evaporate that water more readily, a lot easier. And that's going to grow the strength of these storms. So once again, hurricanes are going to use energy from the warm water in the Atlantic to grow stronger. As long as it has warm water, it will continue to grow. It's why hurricanes don't last very long over land. Once they hit land, they kind of, dissipate and become just strong storms. So the storm surge is water that is being pushed onto shore due to the winds of a hurricane, right? Hurricane winds can be over 100 miles an hour. So that's going to be a whole lot of pushing. So that's one of the things that's dangerous about hurricanes is they are pushing all of that ocean water in front of them as they're moving through the Gulf or through the Atlantic. So when we talk about hurricanes, we usually categorize them, right? and they go on the scale from 1 to 5. And it has to do with the sustained wind speeds. That's the really key thing that separates a Category 1 hurricane from a Category 5 hurricane, right? And you can see Category 1 hurricanes are going to have winds from 74 to 95 miles per hour. The damage is going to be, minimal, not a whole lot. Things that aren't tied down are going to blow around, and it's going to have a little bit of a storm surge. Now, we can go all the way up here to Category 5. Category 5 has no limit. Once the winds start hitting 155 miles per hour, it's a Category 5, and Category 5s can be stronger than that even. And they are extremely destructive, right? An 18-foot storm surge can accompany a Category 5 hurricane. So the damage is going to be catastrophic. Most buildings are going to be destroyed, vegetation destroyed, major roads cut off. This is a huge weather event. So hurricanes, they exist on this scale. All right, I want to end this video by showing you the development of Hurricane Florence. So we're going to see, if you look up here, you can kind of see the Sahara Desert. This is the west coast of Africa. And we've got all these clouds right here showing us that there's a low pressure system somewhere in there. And that is going to be where Florence begins. So you're going to see the hurricane starts as a simple low pressure system. And it starts to move following those global winds west. You can already start to see it starting to develop that, classic swirling shape of a hurricane, not a tornado, of a hurricane, and it's almost even developed an eye at this point. Now it's become a Category 1 hurricane as it's moving across the Atlantic, and it's got a long ways to go at this point, right? This was a very large hurricane. It's going to be fueled by the warm Atlantic Ocean water throughout most of its lifespan. So it's going western across. It begins to drop a little bit again in strength, but we're going to see as it hits the shallow water that's close to the east coast of the United States and that warmer water, it's going to start growing. So you can see right here, here's the eye of the hurricane, right? You can see that one spot right in the middle. And it's kind of amazing, but the eye of the hurricane is actually calm, right? If you were in this hurricane, you would hit the eye wall, which is the most dangerous part of the hurricane, or the fastest winds. And once you get in the eye, it will be calm. So we can see that this hurricane has now hit land. It's a Category 1. I think it hit as a Category 2 or 3. And it's now decreasing in strength. It's going down. It's become a tropical storm. As soon as it hits that land, as soon as you cut off all of that fuel for the hurricane, it's going to start to actually, decrease in strength.